All right, for this test that's coming up, part of it will be from lessons 9.1 to 9.3, and so that's what this review sheet covers. So let's take a look at some problems from those lessons. So you're going to need to know how to solve a right triangle, and that means you're going to be given parts of the triangle, and then it's going to be your job to find everything else. So let's just take a look at number one. This triangle that you are provided with here right underneath number 2 is really going to be, you use that to answer all 3 of these questions. So number 1, we can just replace side C with the number 12. That's its measurement. Side B is going to be 5. And so now it's our job to find side A, angle A, and angle B. All right, so it doesn't really matter. Let's just start with side A. If I'm given 2 sides, then I can just use the Pythagorean Theorem to find a missing side. As long as those sides are not decimals, then that's okay. Rounded decimals give us a less precise answer. So let's just use the Pythagorean Theorem. So just keep in mind, when you're using the Pythagorean Theorem, the hypotenuse is always the C part of that theorem. All right, so that correction needs to be made for some of you, many of you actually, from the last quiz. So to use the Pythagorean Theorem, I'm going to do 12 squared, and that's equal to 5 squared plus, in this case I'm looking for A, so I'll just call this A squared. Okay, and so we go to our calculator if you need to, 144, and then we're going to subtract 25. That equals A squared. I'll just go ahead. I didn't really allow myself a lot of room here, so let me just erase that and we'll come back to it. Okay, so 144 minus 25 is 119. And notice the directions. The directions will tell you, if it said exact answers, then you would just do the square root of 119, and you would try to simplify the square root if possible. But notice this says to round, and so that tells you to go to your calculator and find the decimal form of the square root of 119. So in our calculator, let's go to square root 119, and we're rounding sides to the nearest tenth. So the decimal is 10.908, so A to the nearest tenth is going to be 10.9. All right, so that's one of the missing pieces that I'm supposed to find. Now let's find one of these angles. And it really doesn't matter which one you go for. If you wanted to, for example, find angle A, then you can use, you're always thinking of a trig function here. You're either going to think sine, cosine, or tangent. Okay, so when you're looking for a missing angle, you're trying to find the value of an angle in a right triangle. Then you're going to choose one of these, and it really just depends on what sides you're working with. Okay, so for angle A, I'm given the adjacent side, and I'm also given the hypotenuse. Well, the tangent function is described as, the cosine function is described as adjacent over hypotenuse. So that's the trig function that I'm going to use in this particular problem. So you could have chosen a different way. You could have gone down here for angle B, and you could have, for angle B, now you're given the opposite side with the hypotenuse. So that would have been sine. Sine is opposite over hypotenuse. So you would have been correct either way. All right, so the way you find angle measurements is you use the trig function that applies, and we said we're going to go with cosine. Cosine for angle A is going to be the adjacent side divided by the hypotenuse. And now to find angle measurements, that's when you're going to go to your calculator and do the inverse trig function. Second cosine on your calculator. So let's see what that looks like. Okay, so you do second cosine, and you'll see the symbol cosine. It looks like a -1 exponent. That stands for inverse. Remember, we talked about that back in chapter 5, I believe. Inverse is when you have the little -1 symbol as an exponent. And then you just do 5 divided by 12 in the parentheses. And rounded, again, our directions tell us to round measures of angles to the nearest degree. So angle A to the nearest degree is going to be 65 degrees. All right. And now for the other angle, I'm fine with you just using the principle that all three angles of a triangle add up to 180 degrees. So you can just start at 180 and then subtract off the right angle and the angle that you know, which in this case we found angle A. Let's go ahead and say that that's 65. And then that difference has to be the measurement for angle B. All right, so if you need to go to your calculator, 90 basically minus 65 is going to be 25 degrees. And so we've concluded the all three answers really for number 1. Okay, so I'm going to erase this so we can go back and use this triangle again for answering number 2. Okay, so for number 2, we know the measurement of angle B, and we know the measurement of side B. And so it's our job to find angle A, side A, and the hypotenuse, which is labeled as C. Okay, so we got some choices here. If you need to be working from the angle that you're given. Okay, so that's this 75 degree angle. And so I can find either side A or side C using this 75 degree angle. All right, for example, if I look straight across, I've got the opposite side measurement, and I'm trying to find the adjacent side. Well, the trig function that is described as opposite over adjacent is tangent. So I could do tangent 75, and that would get me my answer after I do the math. Or you could just as easily use that same opposite side from the 75 degree angle and the hypotenuse. This way you would find side C, opposite over hypotenuse. That's the sine function. So either way, just doesn't really matter which way you go. I'm just going to pick one. I'm going to find side A by using the tangent function. All right, so tangent 75 is the opposite side divided by the adjacent side. And then mathematically, to solve for A, I'm going to multiply by A. That cancels out the, just think of it this way, it's going to cancel out the A's. And then I'm going to divide by tan 75 on both sides. So it turns out that to get my answer for side A, I'm going to do this in my calculator. So just go to your calculator and do 15 divided by tan 75 and that's the decimal 4.01923. We're rounding measurements of sides to the nearest tenth, so technically that would be 4.0. All right, so I got my measurement for side A. Now, resist the temptation. Some of you are going to want go ahead and jump into the Pythagorean Theorem, but this is really a rounded decimal, and so for the side measurements, I want you to stay away from rounded sides and just stick with whole numbers. So let's just do what we said earlier. Let's find the hypotenuse side C by using, for angle 75, we can use the opposite side and the hypotenuse, which is sine. Okay, so sine 75 degrees is 15 over C. And then the same kind of deal is going to happen. I'm going to multiply by C on both sides, then divide by sine 75. So what it turns out is it's going to end up being C is going to be equal to 15 divided by sine 75. So let's go to our calculator again. 15 divided by sine 75. And that's 15.529 and so forth, but to the nearest tenth, it's going to be 15.5. And then, so that's side C. And then angle A is the easy one because, once again, just think about what we did over here. You just start at 180, and we know we've got the 90-degree angle, the right angle. We also know we have B is 75 degrees, and so the difference has to be angle A. Okay, so 90 minus 75 is 15 degrees. Angle A is 15 degrees. All right, 2 down, and then one more triangle to solve. So let's just erase this work. Go back to this original triangle. It's getting a little bit crowded. We'll try to partition it off a little bit here. This one's a little bit tricky. You won't have to deal with this on your test, but this is a good way to think a little bit. You're given the measurement of side A as 6 units. And then you're told that sine A, okay, so here's the A angle, you're told sine, which is opposite over hypotenuse, is 2/3. Okay, opposite over hypotenuse is 2/3, but you're already told that the opposite is 6. Kind of curious. So what 2/3 represents is a reduced fraction. So you can think of it this way. What did you have to multiply by times 2 to make it equal 6? Well, obviously that has to be 3. So to make it an equivalent fraction, you have to multiply the bottom also by 3. And so we came up with the hypotenuse must be measured at 9 units. So we're going to call C 9. Okay, so that leaves us with finding angles A and B, and then side B. Okay, well, let's just pick an angle. Let's say, for example, I wanted to find angle A. Okay, so angle A, what do I have? I know the opposite side, which is 6, and for angle A, for the whole right triangle, I know the hypotenuse, which is 9. Well, just think. Again, you're going back to one of these, sine, cosine, or tangent. Which one of those is described as opposite over hypotenuse? Well, that would be sine. So that's the trig function I'm going to use in this particular case to find angle A. Sine for angle A is opposite over hypotenuse. And then again, just remember, if you're finding an angle measurement, you're going to need inverse sine, cosine, or tangent. In this case, it's sine. All right, so go to your calculator and do secant sine, and then put 6 divided by 9 in the parentheses. And to the nearest degree, it's in their calculator, it says 41.81, but to the nearest degree, that's 42 degrees. All right, so angle A is 42. So we'll just go ahead and do angle B. I'm okay with you just going ahead and using the 180 degree principle for the other angle that you're trying to find. So once again, you're just going to subtract off the angles that you know from 180, and then that should give you the missing angle measurement. So let's see, minus 42. So angle B is 48 degrees. All right, so we know our two angles, and now let's find out this missing side. So let's see. So we have choices. We can work with either angle A or angle B. It really doesn't matter. Let me erase some stuff here to clean this up a little bit. I'm just going to work with angle B. Here's my angle B we came up with as 48 degrees. And so I've got choices here. For angle B, I'm trying to find the opposite side. And I can use either, because I know both. I could use either the adjacent side, that would be tangent, or I could use opposite over hypotenuse, that would be sine. So either way, I'm going to go with tangent. We'll just come up here. So tangent 48 degrees is the opposite side divided by the adjacent side. And then to solve for B, I'm just going to multiply by 6 on both sides. And that will give me the measurement for angle B. So in your calculator, 6 tan 48, and that is 6.66, and we're rounding to the nearest tenth, so we're going to say B is 6.7, side B. Okay, so we got angle A, we got angle B, and we got side B. So that's the kind of thing you're going to be doing on those problems on your test, so make sure you're ready. Know SOHCAHTOA really well, know how to find missing angles with your calculator using inverse sine, cosine, tangent. All right, so we have a word problem here, number 4. The recommended angle of elevation for a ladder used in firefighting is 75 degrees. Okay, so you're thinking about a ladder that's leaning against a building, and the 75 degrees is the angle that the ladder makes with the ground. At what height on a building does a 21-foot ladder reach if the recommended angle of elevation is used? So this phrase angle of elevation means basically from a horizontal plane. So let's just think of it this way. Here's the ground. That's going to be the horizontal plane. An angle of elevation is when we take an object, or maybe sometimes it's described where a person looks upward as from a horizontal line. That's also an angle of elevation. But an angle of elevation would be like you start at a horizontal always, and then you lift upward at a 75 degree angle. So that's the angle that the ladder is making with the ground. Because I've had some people say, well, how do I know the ladder, the 75 degrees is with the ground and not with the building? Well, with the building, you don't have a horizontal line that you're lifting upward. You do that with the ground. Angle of elevation always starts from a horizontal, and then you move in an upward direction from there. Okay, so here's the building, and we're assuming it makes a right angle with the ground. The ladder, here's the ladder leaning against the building. It's 21 feet long, and so we want to know where is this ladder hitting this building. So basically we're looking for this height right here. We'll just call this X. What is this height? All right, so we got our right triangle. We have the angle to work with. So we're trying to find the opposite side of that angle. We're given the hypotenuse for the right triangle. And so opposite over hypotenuse again is sine. So sine 75 degrees is the opposite side divided by the hypotenuse. So to find our answer, we will multiply by 21 on both sides. And let's see what that is. 21 sine 75. And that's 20.28. The directions say to round to the nearest tenth. That's one decimal place. So 20.3 feet is our answer. That's the length of that, the height that the ladder lands on the building. All right, number 5. The roof on a house is built with a pitch of 10 by 12, 10 feet high, 12 feet along the horizontal. All right, the side view is given. What is this angle right here? Well, we have the opposite side of that angle, and we have the adjacent side for this angle. So the trig function that is described as opposite over adjacent is tangent. So we're going to do tangent for some angle equals 10 over 12. And once again, anytime you're looking for an angle measurement, you're going to use the inverse, or on your calculator, it's secant in the trig function. Okay, so let's go to secant tan and type in 10 divided by 12. Okay, and it's doesn't say what to round to, but we'll just go ahead and do to the nearest tenth here as well. So to the nearest tenth, it would be 39.8 degrees. All right. Now we get to lesson 9.2, and part of lesson 9.2 is learning how to turn degrees to radians or radians to degrees. So if we want to turn degrees to radians, we multiply by this factor, 180 pi over 180 degrees. And now we look for a way to reduce this, and typically it's not 100%, but typically it's a good place to start. I would look for these same angles that come out of the special right triangles, and I'll go ahead and include the 90 degrees. I would use or look for one of these to be able to use to reduce. They typically are used, and in this case, one of these is 45, goes into both. So if you divide 45 into 315, that's 7, and it's actually negative 315, so we'll call it negative 7. And 45 into 180 is 4, and so that's the way you can write those answers in radians. Just leave it as a improper fraction in terms of pi. So you will not change this into decimal. Don't go to your calculator and give me some decimal form. I'll just leave it as a fraction, reduced, but you can leave it improper. Okay, here's a radian measure, and so we're going to convert this into degrees, and so now we multiply by the reciprocal of that earlier factor. So that's going to cancel out pi, and we can go ahead and reduce here. Let's see, about 4 into 180 goes 45 times. So now we just need to multiply 45 times 9, and that's 405 degrees. Okay, number 8. One of the things that I'm going to ask you to do on this test is to find the length of an arc. And I'll just kind of draw out where that arc is. So we want to know how long that arc is on the circle. And the formula, S stands for arc length, is the radius of the circle times the measurement of this central angle and just make sure that this angle theta is in radians. So already is, so we don't have to do any changing. The radius is 15 centimeters. Theta is 8 pi over 7. So we'll go to our calculator. 15 times 8 pi. And then divide that by 7. And you're rounding to the nearest tenth. And so the decimal on your calculator is 53.85587. So to the nearest tenth, that's going to be 53.9. And since the radius is in centimeters, we always make the arc length units the same as whatever the radius is. So there's my answer for number 8. Number 9, the radius of a child's bicycle tire is 12 inches. Kind of do a little picture here. What's the arc length if the circle, what is the arc length of the circle when the tire rotates 270 degrees? So we'll just say that this is at 0 degrees and it rotates 270. Okay, so basically we're talking about that arc. Well, again, we're going to use the same formula, but as I mentioned earlier, theta has to be in radians, and the angle that we're given here is in degrees. And so we need to do a conversion. So 270 degrees times pi over 180 degrees. You can reduce by 90. 90 goes into 180 twice, 270 3 times. So the radian measure of 270 degrees, which you probably already knew, is 3 pi over 2. So the arc length is going to be the radius times theta in radians. And now you're ready to go to your calculator. And 12 times 3 times pi. And then divide that by 2. To the nearest tenth, that would be 56.5. And again, the radius is in inches. And so that would be the units that we use for the arc. All right, in 9.3, we did some problems like this. We sketched angles. Okay, so once again, I'll just go ahead and label where the quadrants are. So that's 0 degrees. Going in a positive direction, this would be 90 degrees, 180, 270, and then once we go all the way around, this is 360. So to do 330 degrees, that's all the way to 270, and then we need another 60. Okay, so there's 330, and the reference angle is this angle right here. It's always between the terminal side of the angle, so this is called the terminal side, and the x-axis. Okay, it's never, notice on your quiz some people were wanting to make it here, but the reference angle is never made with the y-axis. It's always made with the x. And it's always between 0 and 90 degrees, so it's never negative. All right, so just think of it this way. We went 330, and if we had gone all the way to this line, that's 360. So 360 minus 330 is 30 degrees. So there's the complete answer. You're going to get points for sketching the angle, and then you'll get points for finding the reference angle. All right, let's do one that's in radians. And I know some people are struggling a little bit with radians because it's a new concept. But if you have to, I mean, if it helps, you're always welcome to go ahead and temporarily, I want your final answer to be given in radians, but if it helps to turn this temporarily into degrees, then by all means, go ahead and do that. So you would just use your conversion. And you would cancel out the pi's. 6 goes into both of those. And so really it might be easier for you to think of negative 150 instead of negative 5 pi over 6. Okay, still construct this using radians. Okay, so going in a negative direction, this is negative pi over 2, negative pi. This would be negative 3 pi over 2. And then all the way around would be negative 2 pi. All right, so in degrees, this would be negative 180. This would be negative 90. So we need to sketch out negative 150. Okay, negative 90 plus another 60. Okay, and now the reference angle is right here. So again, make it in radians, but if you think about it, it's going to be in degrees, it would be 30 degrees. All right, so what is 30 degrees in radians? That would be pi over 6. So you need to resist the temptation of calling it negative pi over 6. Just because we went in a negative direction, I think some people are thinking that the reference angle has to be negative, but again, it's never negative. It's always in that range of 0 to 90 degrees, or 0 to pi over 2 if you're talking about radians. Okay, so we're done with those. This is also a 9-3 problem. So let's just sketch out what they're talking about here. We have an angle in standard position called theta, and its terminal side goes through this point. So let's just show this point. It's in quadrant 4. So here's what it's talking about. The terminal side of an angle always comes out of the origin, and it goes through that point. And so to come up with our answer, we're just going to construct a right triangle. You always drop a vertical line from the x-axis to the point. You always put theta here on the interior next to the origin. Label your sides. Some people like to make these negative, and if you do, that's fine. And now let's find the hypotenuse. And once we find the hypotenuse, we'll be ready to come up with our 6 trig functions of theta. So remember, the hypotenuse is always c in the Pythagorean theorem. All right, so let's see what 16 squared plus 12 squared. That's 400, and the square root of 400, of course, is 20. So that's our hypotenuse. All right, so let's run through each of our trig functions of theta. So sine of theta, here's theta. Sine is opposite over hypotenuse. Okay, and in quadrant 4, sine is negative. Okay, just think about the ordered pairs. X is positive, y is negative. So that means cosine is positive, sine is negative. All right, so making sine, we would do opposite over hypotenuse, and it would be negative, and then we just want to reduce that. So 4 goes into both. So sine would be negative 3/5. All right, cosine is adjacent over hypotenuse, and cosine again is positive 4/5. Tangent is, for theta in this right triangle, it's opposite over adjacent. And we also think of tangent as y divided by x. A negative divided by positive makes negative. And then we just need to reduce. And now we'll do the reciprocal. So sine's reciprocal is called cosecant. So we just take sine and flip it over. Cosine's reciprocal is secant. Same thing. And then tangent, of course, is cotangent. And same thing. All right, so those are our answers for number 12. And then to wrap this up, I want you to use the special right triangles. So make sure you know those before the test. I'll go ahead and sketch them out for you. There's the 30, 60, 90. And then give yourself something to look at for the 45, 45, 90. And then you can come up with sine, cosine, and tangent from these. And then, of course, the reciprocals. So we're going to use a combination of reference angles and special right triangles to come up with these values. So make sure you do not rely on a calculator as you're doing this, because you will not be able to use a calculator on your test for these problems. All right, so here's the way I want you to think. I want you to tell me, using a reference angle, basically, what is the reference angle for 135? Okay, so here's 135 when it's sketched out, 90 plus 45. Here's the reference angle. So the reference angle is 45 degrees. The 135 is in quadrant 2. So to put it all together, I want you to answer this by saying, I'm going to find cosine 45 using my special right triangle, remembering that I'm in quadrant 2, so I can make sure I get the plus minus right. All right, so cosine 45, going back to this, so just think about, you can start with either 45. It's adjacent, cosine is adjacent over hypotenuse. So 1 over the square root of 2 rationalized makes root 2 over 2. Okay, so that's cosine 45, root 2 over 2. Now I just have to pay attention to quadrant 2. In quadrant 2, the x-coordinate is negative and the y-coordinate is positive. That means cosine always relates to x is negative. Sine in quadrant 2 is positive. So to finish off my answer, I'm going to put negative because I'm in quadrant 2, and then I'm going to put the value of cosine 45. So that's the way you're thinking about each one of these problems. All right, so let's take a look at 585, sine 585. If you have to do a little sketch, no problem. There's 360. Another 90 makes 450. Another 90, if you need your calculator, or well, I guess you won't be able to use your calculator, so just think adding by 90. All right, so 360 plus 90 is 450, plus 90 is 540, so I'm going another 45. Okay, so that means the reference angle is right here, that's 45. So instead of sine of this huge number, we're just going to consider sine 45 degrees. Remembering that we're working in quadrant 3, where sine is negative. All right, so back to our special right triangle. Well, sine 45 is just like cosine 45. They're the same. They're both square root of 2 over 2. And so in quadrant 3, both coordinates are negative. So that means sine is negative. So my final answer for 14 is just like it was for 13. It's going to be negative square root of 2 over 2. All right. Let's take a look at 1 1/3 pi. Okay, so remember, halfway around the circle is pi. And now I just need to go 1 more third. I'm just going to change this into a mixed number. So 1/3 of pi, which is another way of saying 60 degrees. Okay, so that's the given angle, so the reference angle is right here. So let's not think about cotangent 4 pi over 3. Let's think of it as cotangent 60 degrees in quadrant 3. All right, so we don't really think about cotangent necessarily, but just find tangent 60 degrees. All right, so you're back to this special right triangle, and tangent 60 degrees is opposite over adjacent. square root of 3 over 1. That's tangent. Okay. So tangent 60 is square root of 3. So that means cotangent is 1 over that. And then we rationalize. So cotangent is the square root of 3 over 3. But in quadrant 3, we got to remember, let's think about our sign. Both coordinates are negative, and when we do a negative divide by negative, that makes positive. And so square root of 3 over 3, after we've checked out the plus minus, it's going to be plus, and that ends up being our final answer. All right, let's try secant, and remember that's just the reciprocal of cosine. Okay, so once again, let's get a picture. This is negative 2 and 1/4 pi as a mixed number. All right, so we're going in a negative direction. So all the way around the circle is negative 2 pi. And then we just need to go another fourth of the way. 1/4 pi is another way of saying 45 degrees. Okay, so I'm going to call that negative 2 and 1/4 pi, but all I'm really need to be concerned about is the reference angle. And the reference angle is pi over 4, or again, that's just 45 degrees. So let's see what, well, we've already established what cosine 45 degrees is. We did that over here. That's the square root of 2 over 2. So to get secant, I just flip that over and rationalize it. So I've got 2 root 2 over 2, but that ends up simplifying to the square root of 2. Now let's check out, is in quadrant 4, is cosine and secant positive or negative? Well, in quadrant 4, the ordered pairs go like this. X is positive, Y is negative, so that means cosine and secant are positive. So square root of 2 ends up being my final answer. All right, we're almost done. Get some room here. Okay, so cosine negative 120, that's negative 90 plus another 30. That would be negative 120, but what I'm concerned about is this reference angle. So I went 30, that means the reference angle has to be 60. So I'm not going to think cosine negative 120, I'm going to think cosine 60 in quadrant 3, right? So cosine 60, so we're back to this special right triangle. Cosine is adjacent over hypotenuse, so that makes 1/2. In quadrant 3, both x and y are negative, so that makes sine and cosine. Cosine is x, sine is y, but they're both negative in quadrant 3. So to finish off my answer, I'm going to make it negative 1/2. Okay, one more. Let's think about what negative 1, this is negative 1 3/4 pi. All right, so along the negative, in the negative direction, this would be negative 1 pi. And then I need to go 3/4 along the top. So that's like 1/4, 2/4 is a half, 3/4. Okay, so that's the given angle. What I'm interested in is the reference angle. And that's pi over 4. We had that earlier. Pi over 4 is another way of saying 45 degrees. All right, so I'm not going to think of this as sine negative 7 pi over 4. I'm going to think of it as sine pi over 4 in quadrant 1. Okay, so go to your special right triangle, find sine 45 degrees. I think we've already done that. We said that it's square root of 2 over 2. And in quadrant 1, everything is positive. So square root of 2 over 2 ends up being my final answer. Okay, I hope that helps. And if not, please reach out to me. Come and see me. I think we definitely will have one more class period before the test. So bring questions and make sure you do your own preparation with this review sheet and then prior homework problems, rework them, and do your best to come prepared for the test. And I'll see you next time.